All right, greetings and welcome to the fourth edition of this series, sequence and series we have been considering. All right, so in today's class, we're going to be looking at arithmetic mean, and thereafter we are going to look at further problems on arithmetic progression before we proceed to geometric progression in another episode, episode 5. All right, so do well to subscribe to this channel and of course also hit the bell button. All right, so what's an arithmetic mean? It says, given that a linear sequence is such that the terms are x, y, and z. All right, and we know that our common difference d from arithmetic sequence, since it's an arithmetic sequence, common difference d is going to give us y minus x is the same thing as the second term minus the first. It is the same thing as the third term z minus the second term y. When we collect like terms, all right, minus y go over there and become plus y, minus x come over to the right and become plus x. So we're going to have 2y, y plus y give us 2y equals to x plus z. All right, so can I say that y is equals to x plus z divided by 2. All right, so this is what we call the arithmetic mean. Y is actually the mean of the first and the third. All right, so and you can insert several arithmetic mean between two different numbers. How do we apply this now in solving problem? You say find the arithmetic mean of 4 and 18. Of course, you can say that let the mean n be equals to 4 plus 18 divided by 2, and that will give us 22 divided by 2 equals to 11. Alternatively, all right, you can say let m be the mean. All right, alternatively, method 2, just in case you don't want to use the formula or you forget the formula, say find the arithmetic mean of 4 and 18. That means what number is between 4 and 18, and if it's an arithmetic progression, it's an arithmetic sequence. So you cannot say that the sequence are 4, then m is the number, and 18 comes next. So you cannot see that if these numbers are in AP, then it implies that m minus 4, second term minus the first one, is equals to the third term, 18 minus m. Collecting like terms again, minus m go over to the left hand side, become plus m, 2m equals to minus 4 go to the right hand side, become plus 4, and now become 22. If you divide both sides by 2, our m is equals to 11. All right, so that is example 1. Okay, hope it's well understood. Example 2. All right, it said insert 3 arithmetic mean, okay, between 19 and 35. Insert 3 arithmetic mean between 19 and 35. So what do we do? Solution. So we call the number x, y, and z. So we cannot say 19, okay, the first one. Then the second one is x. The third one is y. The fourth one is z. All right. And the fifth one is 35. Okay. Now, if you look at this, our a is equals to 19, already given. I can call this equation 1. And this is, now if you want to insert, this x is between 19 and y. So you cannot say 19 plus 1 divided by 2 and all that. Well, you can do that, but they're going to have a bunch of simultaneous equations, like three simultaneous equations that will be taking you longer time to solve. All right, to navigate that, since we are given the first and the fifth term, okay, we can say that our fifth term, which is a plus 4d, remember the pattern of general arithmetic term. So have a plus 4d, which is the fifth term, is equals to 35. Okay, this is equation 2. All right, put equation 1 now, a into equation 2. We're going to have 19, all right, which is this a, all right, plus 4d equals to 35. Okay, 19 go to the right hand side, become minus 4d is equals to 16. And when you divide both sides by 4, you can now have our common difference. Our d is equals to 4. All right, so now we have our common difference. What is our x? We can now say that our x is equals to, all right, 19 plus our d, which will give us 19 plus 4 equals to 23. And our y is gotten as x, because when you add d to the next term x, you're going to have y, x plus d, all right, because it's increasing by 4. They're going to have 23 plus 4 to have 27. And of course, our z also is y plus d. All right, that will give us 27 plus 4, and of course, we have 31. Then, of course, to get this 35, add 4 and all that. So we are actually correct. So this is the way we solve problem on arithmetic mean. All right, let's go to further problems. All right, so this we can call this miscellaneous problem 1, because I'm going to take another miscellaneous problems or when I finish AP and GP. Okay, we say number 1, we say a sequence is such that the sum of so that the sum Sn is equals to n squared plus 2n. Show that the terms of this sequence are in arithmetic progression. All right, so we have Sn equals to n squared plus 3n as the formula. Now, notice that we are given a different formula from the general formula, which is n over 2 into 2a plus n minus 1d. Okay, but we are given another formula that represents the sum of a particular sequence. Okay, not the sum of all the general sequence now, but the sum of a particular linear sequence is given this formula. Okay, and we're not asked to show that the terms of the sequence are in arithmetic progression. So what we do when n is equals to 1, we're going to have x1 is equals to 1 square plus 3 into 1, and of course we're going to have 4. All right, and x1 is same thing as our t1, the first term t1. Okay, because sum 1 means that they're adding just the first term alone, while s2 means that they're adding from the first to the second. All right, so when n is equals to 2, that means you're adding from the first to the second one. So our sum 2, okay, is equals to n squared, which will now give us our 2 squared plus 3 into 2. All right, when we solve this, 2 squared is 4 and 3 into 2 is 6. That will give us 10. All right, so the sum of the first and the second one is 10, but we know that our x2, sum of the first and the second one, is adding the first one, okay, which is t1, plus adding the second one, second term. All right, but our t1 has been gotten. Our t1 isn't as our x1, so we cannot say that our sum 2 is the same thing as sum 1. All right, then plus t2. So what is our second term? That implies that our second term, t2, is equals to x2 minus x1, and x2 is gotten as 10. All right, 10 minus x1 now. x1, we had x1 as 4. So therefore, our second term, t2, is equals to 6. All right, I am doing something here. I'll call this equation 2, while I call this equation 1. Okay. Now, okay, when n is equals to 3, what do we have? When n is equals to 3, what do we notice? We are going to have x3 using the same sum is equals to 3 squared, okay, plus 3 into 3. And when you solve, our s3, which will give us 18, okay, that will give us 18. So our s3, all right, it is something as saying the sum of the first two, okay, x2, we have added the sum of the first and the second, the sum of the first two plus adding the third term. Remember, you started from just having the first term, there was nothing to add. That's why your first term, t1, is equals to your sum 1. All right, now we have another term. It implies that our sum 3, if you want to get the sum 3, it is the first two we have added originally plus the third term we now have. All right, so I'll call this equation 3. All right, that implies from this equation 3, that our third term, T3, is equals to x3 minus x2. All right, so sum 3 give us 18. Okay, that will give us 18 minus sum 2 is 10. Okay, so therefore, our third term, T3, is equals to 8. Now, look at the terms of the sequence now. The fourth term is 4. So, can I say that implies the terms are, okay, 4. All right, second term is 6, and the third term is 8, and you can keep on going on and on. Okay, where our D is equals to what? Our D is what? 8 minus 6, which is equals to 6 minus 4, and of course, we have it as 2, which will now give us 2. Okay, so our common difference is constant. So once our common difference is constant, of course, we have proved that the terms of the sequence exist in arithmetic progression. All right, now this equation 1, equation 2, equation 3 I have generated. What do I intend to do with it? Now notice that in the second equation, when we are looking for the second term, it is actually the sum of the first term, okay, plus the second term. All right, so x1 is the first term you already have plus the second term. And in equation 3, when we want to find the sum of the first 3 terms from the first one to the third term, it is as saying the sum of the first 2 you have already. For instance, you are summing up the ages of students in a class. If all of them went outside, the first one came inside, you wrote his age as 10 years old, all right, or as 4 years old. You had it here. Okay, and that is the only sum you have. So that's why your T1 is equal to your S1. If an student comes in and that is T2, second term, and the person is 6 years old, so your sum 2 is the initial sum you had, which was just the first term 4, plus the second person coming inside. So your sum 2 is the first and the second. And of course, sum 3 is going to give us the sum you already had before. First person was 4 years, second person was 10 years, 6 years, making a total of 10 years. So if the third person is 8 years, so it means that your sum 3 will give you 10 you already had before, plus the third person that is entering the class now to give you sum 3. So what does that imply? Sum 2, S2 is S1 plus T2, all right? The subscripts are the same. While the subscript for the S here is 1 less than 2. Here also, the subscripts are the same for the nth term and the sum of the nth term, all right? So while here the subscript is less than 1. So when it is sum first to 3, we have here sum 1 to 2, 1 less than 3. And here is the nth term for the third term. So that implies that we cannot say that sum n, the nth sum, is equals to the sum of the n minus 1, because when it is 3, here is 2 less than 1. Okay, when it is 2, here is 1. Okay, so when it's n going to be here, it's going to give us n minus 1, then plus Tn. So this will represent a formula that connects between the nth term of a sequence and the nth sum of an arithmetic sequence. All right, we might make use of this in future. All right, let's proceed to our example 2. In our example 2, we are told that the sum of the first n terms of n term Sn of an arithmetic sequence is given by Sn equals to 5n squared plus 6n. Find the third term. Find the third term. And of course, just as we have just finished identifying, for us to find the third term, T3 is unknown. T3 is unknown, okay? We are given sum and we're asked to find a term, all right? So it implies that our sum 3, okay, is going to give us sum 2, okay, plus the third term as we established. If we are using the formula xn is equals to xn minus 1 plus tn. All right, so we can now say that that implies that our T3 is equals to sum 3 minus sum 2. Okay, now we can now find. That implies, okay, which is equals to our sum 3 is when n is equals to 3, and here is the equation. So we're now going to have n equals to 3 give us 5, multiplied by 3 square, okay, then plus 6 into 3. So that will give us this sum 3, then minus, when n is equals to 2, sum 2, we're going to have 5 into 2 square plus 6 into 2. All right, so that will now give us what we have there. Upon expanding, you subtract, your answer becomes 11. Therefore, our third term, our 3, is equals to 11. All right, hope this is well understood. Let's look at example 3. It says in a linear sequence, the sum of the first and the fifth terms is 18, and the fifth term is 6 more than the third term. Show that the sum of the first 10 terms of the sequence is 165. All right, now I'm going to solve this problem using an approach of someone who is learning mathematics. The person will simply write Xn because it's asking you to find or show that the sum of the first 10 terms of the sequence is 165. So the person will say Sn is equals to n divided by 2 into 2a plus n minus 1d. All right, that's what the person will first of all do, be that is learning mathematics. Now, when you write this formula down and you now try to insert your parameters n equals to 10 because you are told first 10. All right, when you put n equals to 10 here, what will you put as your a? You put n equals to, you put 10 here, what will you put as your d? So it will not remind you or tell you that you cannot proceed further because you don't have your a and d. So at this particular point, this formula cannot be used now, even though you are going to use it later, okay, because your a and d is not given. So this is the way that we can use common sense, or we can stumble over solution if we don't know from the onset how to analyze the problem. Okay, so since we need a and d, we go back to the question and read it carefully. Now it says in a linear sequence, the sum of the first and the fifth terms. Okay, I must also point your attention to something here. It did not say find this, that it did not say the sum of the first fifth terms is 18. Okay, when the question says the sum of the first fifth terms is 18, means that your n is 5. That means you're adding the first one plus the second one plus the third one plus the fourth one plus the fifth one. So please take note of the English. All right, it says the sum of the first and the fifth, not the sum of the first fifth. Okay, take note of that English there. Okay, it's 18. That means when you say, when you have the first term is a, okay, that is first term a plus the fifth term is a plus 4d. Okay, when you add the first and the fifth term is equals to, you have 18. When you simplify, a plus a is 2a, all right, plus 4d, okay, equals to 18. Factorizing 2 out, 2 into a plus 2d equals to 18. All right, dividing both sides by 2, a plus 2d equals to 9. This will now serve as the first equation from the first statement. Now, remember we need a and d, so it means that we need another information on a and d in order to solve simultaneously. Okay, it says, and the fifth term is 6 more than the third term. Okay, the fifth term is a plus 4d. Okay, that is the fifth term. It says is, and is equals to, in mathematics, is equals to 6 more than the third term. So what is 6 more? Is it multiply? Is it division? Is it addition? All right. Now, when you say, my dad gave me $5 more, okay, it implies that someone, probably your mom, has given you $10 before. Then your dad is now adding adding $5 more. Okay, so more implies addition to what was originally there. So 6 more to the third term. So that means your mom gave you third term, which is a plus 2d, Okay, are you there? And your dad now gave you what? 6 more than plus what your dad gave you, which is 6. And of course, when you simplify this, all right, the whole of this expression can come over here. You have a plus 4d, okay, minus a, if this a come over here, minus 2d, if plus 2d come over to the left, equals to 6, or moving. A minus a is 0, 4d minus 2d will give us 2d, 2d equals to 6. Dividing both sides by 2, our d is 3. We now say we put our d equals to 3 into equation 1. All right, when we do that, we are going to have a plus 2 into 3 equals to 9. And of course, 6 go over here, 2 times 3 is 6, and you have minus 6. So we now have our a equals to 9 minus 6, and that will give us 3. So now we have our a and d. We can now smile and come back to our formula, which is from xn equals to n over 2 into 2a plus n minus 1d. So we return back to this formula now to use it. So now say x1 to 10, that means n is equal to 10. 10 divided by 2 into 2 times 3, okay, plus 10 minus 1 multiplied by d, which is also 3. And of course, when you multiply out, you discover that your S1 to 10 is equals to 165, as was required from the question. All right, so that's taking question B. In question B, what does question B say? Find the sum of the 21st to the 39th term. All right, so how do we approach this? Sum of 21st to the 39th term is what we are looking for. We don't know it. All right, now, how do we approach this problem? To approach this problem, some of this problem will depend on your ability to think, your thinking skills, and how you want to make the problem easier for you. Okay? Now, notice that in mathematics, one of them I want to tell you that the idea is not to suffer you, but it's either to see how you can apply common sense in solving some certain problems. Okay, so a typical student who don't understand, who don't apply logic, who want to be adding, want to get from the first term, which have already gotten as 3, start using the common difference, adding 3, get second term, third term, fourth term, fifth term, sixth term, and all that till the 39th time. The first one start adding manually from 21st to the 39th time. That will take a lot of hours to do. Okay, but how do we approach this using our AP, the sum of an AP formula? All right, so we know that this sum, assuming they have asked us to calculate the sum of the first to the 39th time, n for the 39, I could have just used this formula here and solve and get the answer done. But the problem solved. But we are asked 21st to the 39th time in between. So what do? We know that the sum 1 to 30, sum 1 to 30, okay, or 1 to 39, sum 1 to 39 will give us sum 1 to 20 when you add the first to the 20th term plus sum the 21st to the 39th term. All right, so adding the first, okay, to the 20th term plus adding from the 21st to the 39th term will give you sum 1 to 30. Now this is what we are looking for. So this is how I have this common sense to generate a way to navigate this problem. All right, so if this one go to overside becomes minus, that implies, okay, the sum 21st to the 39th term which they require is equals to the sum of the 39th term 1 to 39, okay, minus the sum of the first 20 term, which is 1 to 20. All right, so now we can now apply the formula for these two to find this particular one. So we are good to go. So that implies we are now going to have for this one, okay, when n is equals to 39, All right, that implies that x39 is equals to 39 divided by 2 into 2. Remember, our a is 3. 2 times 3 plus 39 minus 1, and our d is also 3. 39, okay, is equals to 2340. Again, similarly, our sum 1 to 20, that means n is equals to 20. 20 over 2 into 2 times 3, our a is 3, plus 20 minus 1, okay, and our d is also 3. And 20 minus 1 is 19. 19 times 3 will actually give us 57. Then you plus to the 6 there, okay, you have 63, and 63 times 10, because 20 times divided by 2 is 10. So 63 times 10 will give us 630. So we can now say that our sum 1 to 20, which is S20, is 630. So that implies that x 21st to the 39th time they ask us to find is equals to x 39, the sum of the first 1 to 39th term minus the sum of the first 1 to the 20th term. That will give us 2340 minus 630. Okay. And what do you have? We end up having 1710. So therefore, the sum of the 21st to the 39th term is equals to 1710. All right, so that is the answer to that question. Okay, number 4 question. It says 3 consecutive terms of an AP have sum as 15 and product as 80. What is consecutive? Consecutive means coming one after the other. We don't know whether it is increasing or decreasing. All right, so since we don't know whether it is decreasing or increasing, we can say that let A be the first term. All right, then the second term will now give us A plus D using the general term, since we don't know whether it's increasing or decreasing. And of course, the third term will give us A plus 2D, and to represent 3 consecutive terms of an AP. All right, you say they have their sum as 15. Okay, so these are the terms of the AP of the sequence. All right, these are the sequence of the AP. Okay, so we now have their sum. That implies that the first one plus the second one, A plus D, plus the third one, A plus 2D, is equals to 15. They have their sum as 15. A plus A is 3A, so we have 3A plus D plus 2D is 3D equals to 15. And when you factorize, okay, you're going to have 3, since 3 is common, A plus D equals to 15. Okay, dividing both sides by 3, so they can detach it from A plus D. A plus D is 5. This will give us equation 1, because we can neither find A nor D from just this given equation. Okay, and we are told their product is 80. So when we multiply everything together, the 3 terms together, we are going to have A, the first term, multiplied by the second term, which is A plus D, okay, multiplied by the third term, which is A plus 2D, okay, equals to 80. All right, how do we solve this problem now? Okay, that is because the approach you use will not depend on how easy you want it to be for you. Okay, but if you expand this now, you're going to be having cubic equation in A, maybe a quadratic equation in D. That may give you some problems. So why not you find your D from equation 1? This is equation 2. Okay, why not you find your D from equation 1 or your A from equation 1 and substitute one of them, so that you cannot have your equation 2 in one particular variable. So I will now say from equation 1, all right, that my A is equals to 5 minus D. Okay, if D go to the other side of the equation, 5 minus D, and this will give me equation 1, but it is modified, so I'll call it equation 1B. So if you now put 1B into equation 2, all right, put 1b, all right, into equation 2. So what we have, instead of a now, put 5 minus d. So I'm going to be having 5 minus d, all right, then multiply by, instead of a again, I will now have 5 minus d, then plus the d that was originally there, then multiply by the third bracket, okay, and instead of a, I will also have 5 minus d, all right, plus the 2d that's originally there, all right, then equals to 80. So when you simplify this, d minus d will cancel d here. You're going to have 5 minus d, all right, here, then multiply by 5, okay, because this d minus d will cancel plus d, then multiply by again, minus d plus 2d will give us d, so you're going to have 5 plus d remaining in this bracket equals to 80. Now, of course, you can bring out this 5 outside. I have it as 5 minus d, okay, bracket 5 plus d, all right, equals to, okay, multiply by 5 equals to 80. I just want to take it gradually, dividing both sides by this 5. So you have 5 minus d, 5 plus d equals to 80 divided by 5 will give us 16. All right, so we have this, and this is difference of 2 squared. Now I'm going to follow a very short approach. This sort of expanding now, which some of you could have done, but let's learn to think ahead of time so that we can follow a shorter process. So if I apply difference of 2 squared, all right, I will now say the first one is 5 squared, all right, minus the second one, which is d squared, okay, equals to 16. That will give us 25 minus d squared equals to 16. And of course, my d squared is equals to what? My d squared is equals to what? 25 minus 16. Okay? My d squared is 25 minus 16. And that will give me what? That will give us 9. All right, so therefore, our d is equal to plus or minus 9. Okay, square root of 9, rather, plus or minus square root of 9, which will give us plus or minus 3. So our d is equals to 3 or minus 3. All right, so when d is equals to 3, that implies that from equation 1b, that implies that our a is equals to 5 minus 3, and that will give us 2. And when our d is equals to minus 3, that implies that our a is equals to 5 minus 3. Minus is plus, and that will give us our 8. So our a is either 2 or 8, while our d is either plus 3 or minus 3. So what are we asked to find? We're asked to find the number. So our a is 2 or 8, while our d is plus or minus 3. Okay, so now we have that. Therefore, the two numbers are, so remember we said that the two numbers we are a, okay, a plus d and a plus 2d, representing the three numbers. Okay, so we can now use this now to find the three numbers. So you're going to give a is 2 or 8. So you see that you have it as 2, then when you are using positive, they are going to have it as 2 plus 3 to give you 5, okay, and of course 2 plus 2d, when you use positive d, you're going to have 6, you're going to have 8, okay, or when you use your a as 8, you're going to have it as a is 8, okay, and when you use minus d, 8 minus 3 is going to give you 5. You still have it as 5. And of course, 8 minus 2d, 2 times minus 3 is minus 6. And of course, 8 minus 6 will give us 2. So you can see that they are the same. So it's either it's an ascending number of 2, 5, and 8, or it is the descending pattern of 5, of 8, 5, and 2. So that is the complete solution to this number 4. All right. In question 5, the sum of the first n terms of an AP is minus 45.5. If the first term is at 8.5 and the common difference is minus 7, find the value of n. Okay, let's write the sum. Sn is equals to n divided by 2 into 2a plus n minus 1d. All right, so this is what we have as the formula for our sum. Okay, we are asked to find the value of n. So when we insert, but instead we are told that the sum of the first n terms of an AP is minus 45 and a half. So, all right, our Sn is equals to minus 45 and a half. All right, and our A, okay, is equals to 38 and a half. Okay, and our D, our common difference, is equals to minus 7. So when you plug all these parameters into the equation, okay, minus 45 and a half is in that minus 91 over 2. So wherever I see Sn, I put minus 91 over 2. So I have minus 91 divided by 2 equals to n divided by 2 into the formula 2a, 2 multiplied by 38 and a half, it is in that 77 over 2. So 77 over 2, then plus, we don't know our n minus 1, and our d is minus 7. So this is what we have. So you end up having minus 91 over 2, all right, equals to n over 2 into 77. Of course, these two, we cancel these two here. Then you now expand with minus 7. Of course, minus 7 times n will give us minus n, 7n. All right, and minus times minus 1 will give us plus 7. All right, so we have plus 7 here. Okay, so this is what we have. And when you simplify further, we are going to have or multiply both sides by 2. If you multiply both sides by 2, you're going to have minus 91, okay, is equals to n into 77 plus 7 give us 84, 84 minus 7n. All right, so, and of course, you will expand to have the quadratic equation of n squared, all right, minus 12n, okay, minus 13 equals to 0. When you expand, and of course, reduce to your lowest form. All right, so this is what we have. And when you factorize your quadratic expression, okay, of course, you should be able to solve from here. You're going to have n minus 13 into n plus 1 is equals to 0. And of course, you now say either n minus 13 is equals to 0 or n plus 1 equals to 0. So therefore, your n is 13 or minus 1. However, the value of n is 13. So now say, so that implies n is equals to 13 or minus 1. So can I say, therefore, our n required solution is equals to 13 because we're looking for the sum, all right? So the sum of the first 13 numbers, you cannot have the sum of the first minus 1 number. Right, so n is 13 since n cannot be negative. So your n cannot be negative. So you don't take the negative number, your n is 13. So that is the solution to this one. All right. We are going to stop for this episode. I'm sure that your ability in mathematics is actually increasing. You are learning something from this video, and this video is very helpful in teaching you linear sequence. Okay, please, before we go, please do well to subscribe to this channel so you can have access to a whole lot of videos, okay, that are being uploaded in this channel. And please also do well to hit the bell button so that you can also get notification when videos are being uploaded. Thank you very much once again for your time. We see once again in episode 5, where we are going to be considering geometric sequence.